Alright guys, welcome to RC Mojo. This week we're going to have a look through what's been happening with the Hercules Actros. First, the most obvious change is it's now blue, the same blue that we painted the Grand Hauler. Up on the top you can spot the FPV antenna, and inside you can just about make out some of the wiring. I think we're going to start with a run through of the lights. There's an all-new light controller in the cab, albeit as a rat's nest type prototype at the moment. I was really hoping to have something a bit neater to show, but that's going to take a good few weeks. All the bits and bobs run off a single 2S LiPo, and for control we have a GT3B modified for 8 channels. There's 2 power switches to deal with. The first powers up the light controller, and the second turns on the WP1080 ESC. I've got a microphone set up above the truck, so let's power it up.
Waiting for signal. Calibrating. Drive forward.
The controller has a set of messages that let you know what's happening. Usually if everything's working as it should, you're only going to hear the power up message. Otherwise it'll announce errors when things aren't quite right.
Calibration complete.
All the sounds are 16-bit signed 44.1 kHz WAV files, down converted to 12-bit unsigned for the DACs. So it's really simple to make sound files. Almost every program supports WAV. The controller can play 2 sounds at the same time, so while the engine's running it can do another sound effect without affecting the sound quality. The limiting factor at the moment is the 2.5 watt amplifier and the really quite small speaker. There's a full set of effects for the light mode changes. The sound is a recording of the light switch in my full-size car. Same goes for the indicators, with a separate tick-tock synced up with the lights. The gear shift has a sound too, again recorded from my full-size car. Further back we have a servo-operated coupler that also plays a sound when it opens. The last bit at the back is I installed one of the Tamiya coupler switches, the ones that come with the MFUs, to detect if there's a trailer attached. When there is a trailer attached, there's yet another sound effect. I think the only thing I missed as a quick overview is the horn, which just goes beep, as a horn really should. Before we go any deeper, here's the back of the truck. It's still got the Hercules coupler. After some minor fettling and use, it's perfectly reliable. The only trouble I've had is the suspension rides just a few millimeters high, so it does catch a bit on the front of trailers, but that's quite minor. The widget that looks like a USB flash drive is actually the widget I use to program the firmware for the electronics. It's only there while I'm developing, so I can test the code and debug. There's a WP1080, as close to an ideal ESC for these trucks as you can get. They're incredibly smooth and they've got lots of things to tweak to get it just right. Up on the top we've got the FPV gear. There's more than one camera along with the 5.8 GHz transmitter. If you remove the body pin that holds the cab in place and tilt it forward, we can see the rat's nest. Now it's not the worst install ever, but it's still a bit of a mess. Looking at it from this angle, you can really see the slight bodginess that comes with handmade prototypes. The one thing we can see fairly clearly is the wireless trailer board. It's the same one that works with the old light controller. It plugs into the expansion port and tells the receiver in the trailer what to do with the lights, all fully backwards compatible. I think trying to explain what's going on from here isn't really going to work too well, so let's remove the cab entirely so we can actually see what's going on. The cab's attached the same way as stock. First we've got the 2 screws that attach the front bumper. There's LEDs in there now though, so we have to be a bit careful as there's some wiring that goes up into the cab. Next we tilt the cab forward and remove the screws that attach the stay to the side of the cab. Then at the front there's 2 more screws that attach the hinge plate to the chassis. They come out and the cab is free, except for some wiring. For the moment we'll just unplug the 10-way connector that has power and a few signals up to the cab and just leave it face down. I've got a box under the sun visor, otherwise the little mirror that sticks out the front bears all the weight. I've lost track of how many times that's broken off. You can see even clearer now that it does look a bit of a mess, but it's not as bad as it looks. Next we'll unplug the front bumper. It's got a 2x8 connector. We just pull it out and it's free. The extra little lead is for the lights right at the top of the roof. Now I really need to redo some of these bits just to make them a bit neater. It would be better to use connectors with the right number of connections rather than just use the big blocks. Inside the bumper we've got a nice little loom. Now it's nowhere near as complicated as it looks. There's 5 volts on the red wire which goes to all the resistors, one on each LED, which then connect to the LED anodes. The rest of the wires are one for each function that go to the cathodes. So as an example, we've got pink for the fog light and white for the daytime running lights. The actual connections are all very simple, but making it look neat and tidy is the tricky bit. The only thing left attaching the cab to the chassis is the 3-pin connector for the indicator/running lights on the edge of the wheel arches. We unplug that and the cab can go off to one side. From this angle it's marginally easier to see what's going on, but it's still a bit of a mess. There's lots of long wires, some with high-speed signals which isn't ideal, but it works okay for now. The 10-pin connector that hooks up to the cab has the roof lights, the servo signal and power for the camera switch, more on that later, speaker wires, and the power for the FPV gear. On the main controller board we've got the black and green pair which go off to the coupler switch. Now there's no reason this couldn't connect to something else to trigger a suitable sound effect, it's really just a switch. This bundle is just loads of socket-to-socket servo cables that connect the 8-channel receiver, which is similar to this one, which is buried under the light controller. The connections next to each of them connect to the servos and the ESC. That lets the servo see the pulse width and work just as normal, but the light controller taps into the signal too, so it can work the lights and make noises. These wires are the signals for the programmer and debugger. As mentioned before, it's only there during development. All the lights connect to these pair of 2x8 sets of pins. One row provides 5 volts, and the other row are the 16 switch grounds for the 16 independent lighting channels. Each channel should happily handle a good few LEDs, but that's still to be finalised. The fun part is they can be set up to be plug-in compatible with a smaller light controller, so an upgrade would be literally a 2-minute job. Same goes for the 6-pin expansion. Anything that plugs into the current light controller can just be swapped straight over to the big board and off it'll go. That just leaves the little modules along the edge. First there's the 2.5 watt amplifier. Now when the truck's on its own it's plenty loud enough, but when in a hall with lots of other trucks it does get drowned out, so a bit more power would be nice. Next is the 2.5 amp 5 volt power supply, which provides the power for the amplifier and the LEDs. The third module is just a micro SD card socket. The card contains all the sounds and a setup file, and we're going to have a look at that in a bit. Under the protoboard we have the processor board, which is the heart of the system. It has a 72 MHz 32-bit ARM Cortex processor. It does all the audio processing, signal decoding and the light control. The next step is to design and make a PCB using the modules for the amp, power and SD card, so I can test all the high-speed connections without the maze of wires that we have now. Then once that's all working nicely and all the parts are finalised, we can move on to a single board with everything integrated. Just as a guess, but it should end up being half or 2/3 the size of the current prototype, but only one board thick. Back to the cab then. I've tried to keep all the gubbins as unobtrusive as possible. First, the front-facing camera is mounted inside to the dashboard. It works fairly well. The only niggle is, because the windscreen's tinted, the picture is a little bit noisy as the camera's trying to compensate. The camera angle works a treat though. The roof box is now attached with a couple of very chunky magnets, and the wiring has yet another 10-way connector. With the box lifted, we just need to unplug it and the two separate. This connector carries the connections for the front-facing camera, the speaker, as well as the servo signal and power for the FPV setup. If we look inside the roof box, we have the connector that plugs into the one on the roof, the 5.8 GHz transmitter. Now it's only 25 milliwatt, but that's all we're allowed here in the UK. Its video input is then connected to a Hobby King camera switcher. We have the front-facing as well as 2 rear-facing cameras hooked up, which makes remote reversing a lot easier, but more on them in a bit. Also on the back is the power switch just for the FPV gear. and of course the antenna. Now initially I tried to put the antenna inside the box, but I found with the trailer on, the range when driving away from the receiver wasn't great. Having it up high puts it above the height of the trailer and its metal frame. Okay, back to the light controller now, and we're going to need a laptop so we can have a look at what's on that micro SD card. As long as the truck's powered off, all we need to do is pop the card out, and in this case we're going to need an adapter, but if you've got a micro SD card reader, you just plug it straight in. I'm using Linux, but macOS or Windows will work just as well. All the files are completely standard. I'm using an old card that's been in a phone for a while, so it's got lots of folders already. The one with the light controller stuff is called Mojo. The idea is you can pop a card into the light controller and it will automatically make a folder and a config file if there isn't one already, but that's not implemented yet. In here we have 3 more folders: Effect, Engine and Messages. If we open the engine folder, we can see some WAV files, and if we open one, well, that's the sound file the light controller was playing earlier. Same goes for the messages. Because all these are standard file types, it would be really simple to replace them with something else. A different sound for the engine, or maybe a different language for the messages. You want your truck to swear like a sailor when there's an error? No problem.
Drive forward.
Next we have the config file itself. Now, I'm not 100% happy with the syntax and labels yet. I think it could be a bit clearer. But first we have the input directions. Default will try and auto-detect the best direction, so if a channel is assigned to throttle, it will ask you to drive forward. Otherwise you can set it to normal or reverse to set it manually. The input assignment set up what the 6 inputs do. Those are the connections that go from the receiver to the light controller. This is one of the bits that needs to change a bit, I think. We're assigning a channel to a function at the moment, which does seem backwards. It would be better if we were assigning a function to a channel. Probably a bit more like these ones. These are the 16 outputs with all the current types listed in the comment. 0 to 13 are all 16-bit PWM, so they can dim the LEDs. Head side, for instance, is off when it's off, half bright for the side lights, and full bright when they're on headlights. Outputs 14 and 15, however, can only be full on or full off. To assign a function, it's just as simple as typing a function type in between the quotes. Then the next time the light controller powers up, that's what the output's going to do. Now for the really fun bit, we have the mode assignments. By default, the controller powers up in mode 1. Then, just like the smaller light controllers, we can use the increment-decrement input to switch between them from the transmitter. Currently there's 10 modes available, and it'll automatically stop when it reaches a blank one, but it would be simple enough to allow for 100 modes, which should cover most use cases. Now we have the file paths, and none of the engine and sound effect file names are fixed. That means you can sort the sound files however you want inside the Mojo folder. These are the individual volume controls. Now it's worth noting that the DAC always outputs at its best quality. There's a 2-channel serial controlled volume pot that then gets mixed together, so turning the volume down doesn't lose any quality that you're ever going to notice. Although on a small speaker you probably wouldn't notice anyway, but if there's enough space for a decent speaker and enclosure, it'll get the best signal the light controller can put out. The last 2 entries are the engine timeout, and that's how long the engine will idle when the throttle's at neutral before it all shuts down. And lastly, there's the deadband for the throttle, which you set so the brake and reverse lights turn on at the same time as the ESC starts to drive the wheels. 5 covers most, but some ESCs have a huge deadband. Now I suppose that just leaves seeing the FPV gear working. Now I've already powered up the truck, so the RC gear's all up and running. We just need to connect up the FPV receiver to the laptop. Now I've tried a few of the USB receivers now, and this dual antenna E-Ashine one seems to be working the best. There are better receivers around, but they tend to output composite video, which requires a few other bits and bobs to make a working system. With these USB ones, they just plug straight into a laptop, and they work pretty well. The receiver shows up on the laptop as a standard USB webcam, so any software that can record from a webcam will work just fine on any platform. I'm using OBS here, which has got a nice simple user interface, and it does the job perfectly. We can turn on the transmitter now. The switch is just off the top of the frame, but it is there. We just need to switch it on and the truck's transmitting. To tune in the receiver, we just hold one of the buttons down and it'll do a band scan. These slightly newer receivers have a rather nice on-screen display that shows where there's signal, and it'll lock on to the strongest one. If there was other FPV systems around, there would be more big peaks. What you're seeing on the screen at the moment is the front camera. If I stick my hand in front of it, it's a bit more obvious. There's a little bit of latency there, a very slight delay between me moving my hand and the video catching up. But for the speed that these trucks do, it's not really noticeable when driving around. For a fast RC, you might want to do something else. This setup really comes into its own when we use the camera switch. By pressing what was the throttle trim buttons on the stock radio, we can switch to the reversing cameras. There you can see the carefully piled up junk that's always just out of shot. The other side's got a bit less to see, just the window and some wall. The trick is though, when driving and trying to pull a trailer around a tight corner, you can look down the inside and make sure you're not going to scrape a trailer on a wall. When reversing, you can line up fairly well in loading bays too. The cameras would be better on the outside of the cab. At the moment, if you're going absolutely straight backwards, you get a good view of the front of the trailer. But I thought it was a fair compromise, so the cameras didn't look out of place on the model. So that's about it then. That covers most of what the truck can do, except for the rear lights, which for some reason I completely forgot to film. But they do work, honest. Hopefully at some point in the future, probably the far future, we will have a descendant of this available to buy. To put it into context, it's taken me 4 or 5 months chipping away at it in my spare time, that I'm not doing other things, to get this far, and it's still quite a long way off. Anyway, that's it for this week, so thanks for watching. Like if you liked, subscribe if you haven't, and leave a message if there's something on your mind. Bye guys!